Do I really feel like doing a live stream today? Yeah. I thought that was a good title for this video because that's how I feel right now. So what should I do a video on today? I've got a lot of code here. Programming my PCB, which I made in KiCad, which is now visible here. So I have a motor control board that communicates over CANopen with this control panel board. It's the same board, it's just in here. You may imagine that, well, why is it that's way too expensive to have two boards that has so many components on them, where one is just driving motors and the other one is connected to all the switches. Well, it's actually quite practical to do it this way, because I have the same firmware that runs on both, and I just switch between the master or slave using the CAN address switches that I've placed on the board right here. Hello, Damien. What do you think I should make a video about today? Let's see how long my dog is going to let me film. How long is YouTube latency today? 5 minutes? 10 minutes? So, I have set up a few accounts around the internet that are going to make my streaming a bit easier, and also open up for new ways to communicate. So, for example, I have set up a Discord account with, for now it's just 2 channels. One is for programming, and the other one is for electronics. So if anybody watching this video feels like you want to ask something, or you want to start a discussion about something, make a suggestion, just follow the link in the description and join the Discord page. Let me bring it up. Where is it? Got it here. Gotta check if the link works. Oh no. This is gonna be no. I don't want to leave this page. This is an important document. Probably the most important document when programming in STM32. So I'm gonna leave that on, and can probably take this one. I discovered a bug in my driver for this MCP 2317. Which caused the I/O pins to not have any pull-up resistance. So I was just writing to the last bit. I discovered that when trying to read the CAN address sensor. Anyway, let's see how this works. So obviously, when I'm looking through this window, I have to create an account and whatever. I'm just gonna move another window. Come on. There is 2 channels now. There is 1 user, Kaz Akar. Congratulations on being the first user to join my Discord. Kazakher is gonna just leave just after I said that. We'll see. And another thing that I've been thinking about is that, well, this is actually something that I've been sort of offering while I do the videos, and it's, for example, if you guys have any questions regarding the hardware I'm working on, or you're curious about how I work with the device tree in my firmware, and those are the types of questions that I'm ready to answer when I'm live streaming. So kind of like part of the live stream is to, like, I want to make the live streams more fun, and part of that is me answering any questions that come up spontaneously. And I think that's probably the best way for me to answer a question, because I have my mind already set on whatever I'm working on, so I can give an answer that is going to be many times better than an answer that I would give in the comment section when somebody just asks something out of context about some code that I haven't touched in 6 months. So if you feel like asking any questions, just feel free. Don't hesitate to ask them directly in the live chat. What's left to do with your board firmware for the board? What's left to do is I have to connect the switches, and I want to connect them to the spare button inputs. Let's see. I'm going to bring up the camera here. So I have 2 switches here, which take 4 channels, and 3 of them I'm going to connect here, and another one I'm going to connect to the spare input on the encoder interface. 2 of them are currently connected and they work, and 2 of them I wasn't able to connect to the spare high voltage inputs. I wonder why. What problem did I have? Maybe I can explore that a bit later. But I need to solder like longer wires to them so I can connect them to the opposite side of the board. Then it's the next thing that's also important to do right now is getting the timing of the ADC sampling right. So the way that the way that this board samples current is by looking at the value of the current sense resistors, and there are 2 current sense resistors which are placed on 2 of the MOSFETs, and those values, they have to be sampled in precise time points, because it's not during the whole cycle that you get a current reading. You only get the current reading when the high side MOSFET is on, and like when there's current flowing through the resistor. So I need to get that working, which is basically just means getting the timing right. So triggering the ADC at exactly the right time. What else is left to do? Yeah, so when I get the current readings right, then I can run the motors in current control mode, and those are basically DC motors right now. So it's rather simple to drive them, but I still would like to drive them in current mode so that I don't get so that I can have constant torque, and also so that I don't get this overcurrent condition if I suddenly increase the voltage. Without following a ramp, just suddenly go full voltage, then there is always this current peak that can be quite high, and that can actually it wouldn't usually damage the board, because the board has overcurrent protection in the DRV chip, but it can sometimes put the DRV chip into a fault mode where you have to actually power down the board and power it on again in order to get the DRV chip to switch the MOSFETs again, and that's something I really don't want, because that can just, like, you're just controlling this thing, and then suddenly everything just dies and you have to like power it off and power it on again. It's just unacceptable. So that's the step after fixing the current readings. And what else? What else is there to do? Well, in terms of things that are non-critical, but that would be interesting to make sure that they work, is the LCD interface and the EtherCAT interface, and also the analog out, which is the same concept that I use for setting the overcurrent set point on the DRV chip. It's an analog. It's an I2C I2C potentiometer, which I can set the value digitally, and then it basically sets the resistance, so I can vary the voltage on the overcurrent pin. And that's for the low-speed analog outputs. And also improving in terms of firmware, getting the I2C driver to use interrupts and to be completely non-blocking, because my current I2C driver is basically a very simple I2C driver, which takes up 100% CPU usage. I don't use this way of doing things anywhere else in the firmware, but just to get this driver running, just to get just to get sort of the higher level components working, I just put a very simple driver which just uses while loops while waiting for I2C events, and that driver alone is taking up like 50% of the CPU. So getting that to use interrupts and to use message queues that the threads can sleep on is very desirable. So by the way, when I say non-blocking, I mean code that doesn't block the CPU. So if code sleeps on a semaphore, the code is not running, so it doesn't block the CPU. There are different ways of interpreting the word non-blocking. Like some people think that it's code that runs like a event loop, but that's not what I mean. Let's see. So it was you, Damien, that joined Discord. I see. So now you know what to do today. Maybe work around ADC soldering. I don't know. On my side of things, I need to investigate why BME 2800 spits out garbage. Like it's not that I don't know what to do today. It's more like I kind of feel like just taking a little break and not do anything. Do you mean BME 280, by the way? So maybe I can demo this thing. Let's see. I need power. All right. Now you can't see the servo, but it's actually rotating. And the cylinder is moving as well on the back. So now it's like setting the default position and then programming the home position, and then I can program different positions here, control the speed, intensity, like acceleration basically. Yeah, so these buttons are basically like presets for different positions. And the can open interfaces. I'm gonna check if there is. I'm gonna check how my traffic in can open looks like, because ideally I want to get the can open packets to kind of always look the same, like be sent at exactly the same times at each frame. Unfortunately, that doesn't always work that way. Let's see. So vertical scale. Looks a bit better. Okay. And then I wonder if I think that this message. No, actually, I think that it's actually this message that. Yeah, it's this message that sends the motor command from the control board, so the control board to the motor board, and then this message is the returning message from the motor board to the control board, telling it where what position the motors are in and what current the motors are consuming currently. So each frame is 1 millisecond, which is configurable through the can open interface. And the master sends a sync packet, and then any data that it needs to send to the slave, and then the slave also responds with any data that is relevant to the master for this time frame. And then they get sent like this every millisecond. So I got the timing pretty good. It's not always perfect. And the reason that it's not always perfect is because even though the can open program runs at highest priority, there is still a lot of other things that happen, which can sometimes offset the time. But it's within the limits. Plenty of plenty of space left, or plenty of bandwidth left for more data. Damien, why, in terms of 0.1 millimeter wire, why don't you just take a cord, like a power cord, and open it up and take one of the strands of the wire? Yeah, that's all too common, that boards don't turn out right on the first try. The buttons are from Mauser. Let's see if I can find the buttons. There's plenty of LED buttons that look very similar. Different colors too. And I really like the PWM LED driver that I use, even though it's I2C driver. I still like it. One of the things that I discovered, which I didn't give some thought to before, is that because I have several chips, I have 4 chips connected to I2C bus. So if one of them misbehaves at startup, like for example the chip doesn't get reset properly, for example the LED driver, which was one of the chips that didn't reset properly, then all the others don't work either, because that puts the I2C bus into undefined state. So it's very important to wire reset signals for chips, making sure that at least you can either like disable or reset every device that's connected to the I2C bus. With SPI it's a little bit different. Like it's much simpler with SPI. But here you have the enable pin, for example, that I can use to disable and enable the chip. And I have to make sure that the default value for the enable pin, when it's configured as a GPIO on the microcontroller, that it's low and not pulled up high or something like that. I've had a few issues with the DRV chips when they enter into overcurrent, for example. According to the datasheet, I should be able to reset the fault by toggling the N pin, but I tried doing that, and sometimes I can't do that, and that really annoys me. Of course, one of the solutions is to never reach the overcurrent set point, but just in case I ever reach the overcurrent set point, I still want to be able to reset the fault signal that's coming out of this chip. And also having test points. I added a few test points here. Like having test points on these signals is just so useful. By the way, what the hell happened to this one? This one, I seem to have missed this one. Like that. So I just added several of these test points. They're not even annotated yet. But test points are insanely useful for any signal, especially when this chip is a QFN package, so it's hard to reach the pins with a scope probe. Very nice to have test points. I make lots of use for these test points. These test points are very useful in debugging any communication issues. I've also burned a MOSFET, which I think was caused by a solder bridge underneath the MOSFET, because when I removed it, I found a lot of solder that was way too much solder, but I guess I'll never know. When I replaced the MOSFET, the rest of the circuit was working, so that's fine. I was quite happy about that. But the MOSFET literally just went up in smoke. Very happy about the overcurrent limit. This way of setting overcurrent limit is really nice, using this digital potentiometer. Yeah. And also, maybe I will get the USB working. It's not very critical right now, but it would be nice. PMS 7003 air quality sensor. Laser dust sensor. Mouser got back to me about the connector, and their answer was very, like, almost rude. But the way they seem to work is that they forward messages to different departments, and when the message gets back to me, it says, well, you did get the connector that was in the datasheet. And then they comment on my picture. So I sent them a picture where I have a connector that looks like, let's see, where is the connector? So this is what this connector looks like. This connector does not belong here. And Mouser replies like this. So let's see, where's the reply? The latest reply. Thank you for your patience. After our product department looked into this, it seems like you have received the correct part. According to the datasheet, it should be a 3-pole part. And like, the datasheet looks like this. It's not the fact that it's a 3-pole part. It's the fact that it's the wrong part altogether. This part in the datasheet has the screw holes. And it has 2 rows of pins, which I designed for. But the part that I received, and the part that the factory received as well, which leads me to believe that this is something wrong in the distribution chain, is this part, which is not the part in the datasheet. And I basically sent a reply specifying that exactly what I just said. And Mouser replies, "Hello, thank you for your reply. We have forwarded this to our product department for a closer look." So now it's going to take like 2 weeks for a reply to come back to me. We'll see if it's going to be exactly the same reply or a different reply. But until then, I have found better connectors, which I'm going to be using instead. I'm going to be using a similar plug that goes in here. So this This is a connector that has a little, like it's a small wing here that basically clicks into the plug and keeps the plug in place, which is rather practical. I can imagine, though, for a company like Mauser having millions of products, when something is wrong with a single product, they and when the customer service is not actually where the warehouse is, then it becomes problematic and time-consuming to debug any issues with the distribution chain. Like somebody probably just put a wrong bag of connectors somewhere where they shouldn't be. So or it's just something wrong with the database. They just put a wrong article number on that product. Maybe I can check exactly where my ADC is sampling. So my ADC is implemented here. It uses it samples in three, like it does a parallel sampling of all of the ADCs, so 3 channels at a time, but only 1 channel per ADC, and there are 3 ADCs on this chip. So I have to pick channels so that I don't choose the same channel for 2 different ADCs, which wouldn't make any sense either, because they all have channels connected together on the same pins. Anyway, so the way this works is, the way this is configured is like this. So I got all of my ADC channels in 5 groups. And all of the channels all the channels that have to be sampled simultaneously must have the same sampling rate. I use 28 cycles. It seems to work. But what I need to figure out now is exactly where this sampling is starting. So the way I've configured this is that it's triggered by the timer capture compare. So there is different ways of triggering it. One could trigger the ADC on timer update or capture compare on any one of the channels on the timer. So my ADC for motor 1 should be triggered at timer 1, channel 1, I think, capture compare, which is not perfect. So I have to look at a few different options. The triggering on update is only available for injected channels. So maybe I would need to configure the injected channels and use an injected group instead in order to sample in the middle of the cycle if I want to do that. But I'm going to check now if I'm going to check exactly where I should sample and where I'm sampling right now. So let's see. So the question is a little bit like, what's the best way to do that? I could check the value of the ADC, and I could check exactly which capture compare channel it's triggered by. Let's see. Where do I configure the trigger? Right, I have the trigger hard-coded here, which is not optimal, but I was going to test this and see how this works. So I have timer 1, CC1, and I probably need to make this configurable because I don't want to use the same. I don't want to use timer 1, CC1, for motor number 2 because it's driven by timer 8, so it has no relationship to timer 1. Eventually, I may actually sync those timers so that they fire at exactly the same time. But in terms of configuration, this is obviously not correct. So I'm gonna make this into a device tree variable and configure it for each ADC. Let's see. And default is actually -1. So I see. And there's another issue here, which is the fact that ADC 2 and 3 are actually triggered by ADC 1. So we can actually only have a single trigger, which means that it's an absolute requirement to synchronize the timers. And right now I don't think they're synchronized. I'm going to check. So let's see what the scope says. So on my first channel, or the first motor, I'm gonna just pick one signal line. So my first motor, I have this. I need to zoom in. This. No, that's too much. And the second motor, looks like this. So it's kind of, the difference is the time it takes to run the code between like initialization of each timer. So since they're all initialized in sequence, like according to the device tree, and presumably the second timer starts a bit later, which of course is the case. But this means that sampling is going to be wrong for the second motor unless I synchronize the timers. So I'm going to go to the bathroom and then I'm going to check the datasheet for timer synchronization. So, in order to get any kind of reasonable reading, by the way, I'm gonna check also the waveform of the current, because I want to know which pulse it is aligned with. It should be, let's see, ideally I should be, yeah, I should be keeping the joystick down as well. Huh. Where's the current? There. That's the right. Yeah, that's the right test point. So. Oh, I have to lift it up a little bit. Otherwise, the cylinder hits the table. I need to come up with some way of like loading this cylinder so I can get higher currents. Maybe like screw it to the table or something. Screw the shaft to the table. Okay, so this is there's very small variation there. I need to zoom in a little bit more. You can actually see what the variation is. Let's see. I wish there was an option in the DS Remote to unlock the controls of the scope. Because when DS Remote is connected, I cannot change settings directly on the scope. Maybe this is better. Yeah, that's a little bit better. It's a bit noisy though because I don't have the grounds connected, but it will do. So when this first channel is low and the second channel is high, no. Actually, yeah. So when that first channel is low, because this is the first channel of the current sensor, so then I have the second channel of the current sensor, which looks a bit different. This is rather weird waveform. I wonder why it has this waveform. Like, it's not spinning, there's nothing drives this, but it looks different. The proper place to sample this, if I were to measure the current based on the first channel, is to sample it slightly after the falling edge of the PWM cycle. And I have external trigger conv edge set to rising, so I'm gonna set this to falling. And I'm also gonna check the values that I get right now. It's obviously sampling in the wrong place, most probably. I'm gonna see if I can get anything better by just making this little change. Oh, of course. So if trigger this doesn't even matter as much anymore when I'm only configuring one ADC for the trigger, but I could still make this available in the device tree. And then I think I can use that define. I think I have it defined in the device tree headers as well. So I can just set this like this. ADC, trigger, external trigger T1, CC1. While I'm at it, I'm just going to add the edge as well. External trig con edge. Is this defined? Actually, let's make this none. I feel like I misspelled this. There's something weird. I cannot see exactly where I misspelled this. External trig comma edge. Yeah. Let's see. Yeah, looks exactly the same. But I didn't get completion suggestions when typing it. Yeah, and this is going to be just trigger edge. And actually, I could set the defaults directly. So I want to set this to a default only if the trigger is specified. So I'm going to set this to rising. Okay, should build now. Conversion, yeah, even 32, of course. Oh, and another little issue here is that when I have the motor drive board running, then my ST-Link doesn't work. So I have to turn it off, and then I have to reflash. See. Well, this seems to produce better results. So let's see here. At least for the pitch channel, which is, yeah, I would kind of expect the yaw channel to work. Or no, wait. I think I was just looking at the wrong value. Yeah. Change there. I'm going to drive the cylinder all the way to the back so that I can sort of load it. To make it consume more current. Yeah, you can kind of see the change there. But it's not that much. You can see that that value going to like 2,300, which is, in this case, it's let's see. I wonder if that is the raw ADC value. Let's see what I'm printing out. Yeah, I'm printing out the raw values that I receive for the current measurements. So I have to actually do something. I have to reflash the driver board. But before I do that, I'm gonna synchronize the timers. So I think that's an important thing to do. So timer synchronization on STM32. I want to synchronize timer 1 to timer 8. Timer 1. It's going to be some combination of the external trigger, but I have to look up exactly how to set it up. Let's see. This one's still searching. Seriously. Have they started to require login? I found it faster than the search function. Something's wrong with the search function. It just doesn't search. Okay, so synchronization. Where is synchronization? External clock, source mode, trigger. External trigger synchronization. So, I'm going to configure timer 8 into slave mode. Let's see. Or maybe also reset mode. So, let's see. The counter is prescalic initialize in response to an event. The trigger input. The thing that is not really clear to me yet is how to configure the timer 1 as trigger for timer 8. Let's see, gated mode is where it starts, I think. Yeah, it's enabled when the level is high, for example, on some input. And trigger mode. Yeah, I think it's reset mode is probably the correct mode for it. Starting 2 timers synchronously. No, I don't think that's not the use case. Not really the use case. It corresponds to what I want to do. But using one timer to start another timer. Maybe something similar to this, except not on the update event, but rather on the enable event. And I'm going to check the code for the STM library and see what function I could use. Select output trigger. And I'm gonna do the reset mode. So I think that reset mode should reset the timer when it receives the trigger event, and then I'll configure the trigger event to arrive from timer 1. So let's see if I can make this work. Okay. It's like the beauty of being able to go to the definition of any tag, like not just code, but any tag. Just go like this. I think the code completion in Vim is very simplistic, but in certain ways it works a lot better than any other code completion that I've used. Let's see. So, slave mode, if it's 0, then we can assume that it's not used. So let's see here. So I'm going to configure this only if it's not set as encoder. If it's not running in encoder mode. If slave mode. Tim slave mode. Select slave mode. Let's see. And then sets or resets the slave mode. Master slave mode. Master slave mode. Okay, and then for the first timer, the timer 1, I should probably set master mode. This is just a bit. And it could actually be possible that master and slave modes can be used simultaneously, because one timer can be a master of another timer and also a slave of another timer. So I'm going to leave this if statement just as an if statement and not an else if statement. Okay, so I configure the first timer as master, the second one as slave, and then I need to pick the trigger source. Configures the external trigger. I think external trigger is the actual pin that sits on the chip. So I'm looking for something else. Select output trigger. Right, okay. So this is important. This is going to be configured for the timer 1. And should I use this as maybe if I configure the second one in enable trigger mode, slave trigger mode enable, and then I just enable timer 1. Or I just want to check if this bit is set every time the timer rolls over. Update generation. Ah, okay. So okay, so what is the way to do this then? Let's say I set this to Tim TRGO source reset. And maybe I would need to initialize timer 8 first. Okay, so this sets also the MMS bit, so I can just do this every single time. I have to make sure that the option actually exists. So if output trigger not -1, and I set this output trigger. Okay. And input trigger. I think that input trigger should be selected. Let's see. ETR. I think that different input triggers can connect to different peripherals. And there are different tables for input triggers. Did it wrap around? Yeah. Okay. let's see, from timer 1. So this is basically what I need. So I configure timer 1 as master mode and set the trigger output to update event. So yeah, and configure timer 2 to get input trigger from timer 1. So SMCR. And then I can check the library to see where this register is updated. Which I think I need the table. I think the table would tell me exactly which source to use. Configure timer 2 in trigger mode. Trigger mode. The counter starts at the rising edge of trigger. So either reset or trigger, I think, would work for this. So I could start timer 8, and then once, so I'd have to initialize timer 8 before timer 1, and then once timer 1 is enabled, then timer 8 is reset. Okay. So the only question here is, what does this mean? Getting input trigger for timer 1, which is, I think, dependent on which timer I'm configuring. Okay, so where is this SMCR? Maybe I had some comment here that explained this. Doesn't explain which source this would be connected to though. Where is the mapping of the timers? I remember seeing that diagram somewhere, but I don't remember where. I can't find it now. Yeah, really annoying when traces break. I had one of the pads on the STM32 got sort of, it came loose from the board. So I managed to kind of, because I was resoldering the STM32 several times, and I had to sort of tuck it in underneath the chip and then just make sure that all the pins around are properly soldered, and then now it's kind of sitting in place and I just don't want to touch it. And it seems that all of the pins are soldered properly now, so I get all the peripherals working. But yeah, that's very annoying. Isn't break function. Where are the tables about the external triggers? Ah. Yeah. There they are. Look at this. Alright, so timer 8 would be the slave timer, and I need to set this to ITR 0 in order to get the timer 1 trigger into timer 8. So that answers that question. And now I just need to configure this. Let's see, so select if input trigger more than -1, tim select input trigger unit 32 input trigger input trigger. I just need to add this input trigger field here. And I go to tim 8, configure input trigger to tim ts ITR 0. And what I also need to do is move this timer higher up. I don't think it depends on anything. So I'm going to make sure that this one gets initialized before timer 1. Because this one is going to be the slave of timer 1. So I'm going to move this block higher up in the device tree. Okay. It's time to test this. UN16. Okay. So master mode is UN16. I'll make it UN16 here. And probably slave mode as well. Yeah. Slave mode as well. How stupid of me to do this. Let's see. This would be UN16 as well. Output trigger and input trigger. Input trigger. Okay. Write complete. Awesome. And let's see. So I'm gonna check with the scope whether the timers are aligned now. Maybe they don't work at all. In which case, I will need to stop this video anyway and come back to this later. Okay. Well, they don't seem to be aligned. Right. I think I know what the problem is. Slave mode enable, and also, of course, I need to start this in disabled mode. Let's see, let's add a mode. Add this enable variable. And enable is going to be 1 by default, if not specified. And then tim command enable. Okay. It seems to be that I have a redundant enable here. I'm going to remove that enable. Just have one enable. Let me try this. Okay. To see if this is running. In sync. Wait. Power it on first. What is that artifact? I haven't seen that before. Something is happening, but it's not the correct thing happening. master mode, slave mode, enable. It just enables master mode. And trigger output is supposed to be not update. It's supposed to be enable. Okay, so it's still not synchronized. So, trigger output source enable, and trigger input okay, so because I swapped places this section, so I put actually enable in the wrong place. Enable 0 needs to be here. This is the timer I'm going to start disabled. Okay. And now it's actually not running. It's actually not running at all. It's not being enabled. Why is it not being enabled? Yeah, and slave mode enable. Yes. Okay, I'm gonna review this again because I think I wrote some options in the wrong place. So trigger output is enable. When this timer is enabled, it's gonna trigger its output. And then on the timer 8, we have input trigger set to ITR 0. Which means output from timer 1, and slave mode is enable, and this one is started disabled. So let's see if this works now. Okay, time to check. It is not running. Only one of it's running. So what is up with that timer? Okay. What if I go back to this? I set slave mode reset. And this could work as well, actually. And this one will trigger upon being enabled. Or maybe this could actually trigger upon being reset as well. I'm just gonna quickly check if the timer is running. Yeah, it's running. Okay, so it's time to see if they're synchronized. Okay, here's my electrode. And we got motor number 2 and motor number 1. Not really. They're running, but they're not synchronized. Oh, I have to reflash because I just saw that there's an error there. Let's see. Now it got verified. Okay. They're still not synchronized. It's exactly the same problem. Exactly the same issue. Trigger output. Master slave mode. Okay, actually, let's see. Is this correct? Yeah, slave mode reset. Do I actually need to enable master slave mode? Maybe I do. Master slave mode. Sets or reset master slave mode. Synchronization between current timer and its slaves. Let's see. Input trigger source. Master slave mode. I'm gonna check the datasheet, what it says about SMCR. MSM. The effect of an event on trigger input is delayed to allow perfect synchronization between current timer and its slaves. Okay, so this master slave mode. It does seem that this should be only set for the master. Input trigger, enable 1, slave mode. What was the trigger mode? Event source. The counter starts at the rising edge of the trigger. Yeah. It sounds like this is actually what I need. Slave mode trigger. Okay. Let's start this disabled. Okay. I'm going to check this and see if this works. doesn't work. It's the same behavior. It's still not really working here. Still an offset. Maybe I'm not setting the bits correctly. Maybe I'm doing something wrong here. In my initialization here. So let's see. Slave mode. Trigger. Output trigger, input trigger. But it actually starts, so that's an improvement. So in trigger mode it actually starts, but it's not. Okay, I'm gonna do like this. I think this is reasonable to enable PWM outputs. Let's enable. Or actually, no, this needs to be set, because enable is going to be triggered by the input to the input trigger. Okay, so this is running in trigger mode. So this can be trigger or reset. Should I try reset again? Master slave enable and maybe, let's see, maybe it's something about this. TRGO. What other sources do I have? Source reset, enable, and update. Yeah, I'm pretty sure I need to have this set to enable and update. That's not what I want. Okay. I could try update, but I'm gonna try flashing this, and then I'm gonna try update, and if that doesn't work, then I stop this video and continue later. Let's see. Oh, check this out. Awesome. This is very nice. All right. So, problem solved. This is actually working. So, I had to do it like that. If you know a better way, comment on the video. Otherwise, I hope you learned something. Is this not live anymore? Or what? Like, the YouTube stream that I see being sent back from YouTube is way behind. Like, really way behind. Okay, there we go. I think I can stop the stream now. Without losing the end of the video. Almost there.